Hey, welcome to all of you on Infinity Learn. Now this is a special series that we have brought into. I know that all of people are gearing really for JEE Main examination, and for that wish you all the very best. I hope your preparation is going on full throttle. There is no problem whatsoever. Practice more, that is the only way out. Now I thought, or rather we decided that this is the right time to launch something regarding JEE Advanced, because you will have ample time and opportunity to really work it on the place and to decide in which line you have to attack for the rest of the time. The point here is that at this point of time there is rarely any opportunity or scope to learn something new. I mean, you have to bank on the things which you have already learned. You have to proceed as per your structured and designated way of preparation. But in this particular series, what we will do, we will bring out some applications, not exactly the theory we will be intending to cover. We will bring out the application part of the most probable things and where student goes wrong. So we know that probably where you can go wrong, we know that where you can get stuck, and those are the things which we will bring through applications. It's not direct embedding the theory, but we are bringing the things through applications. There will be a problem, and around the problem we will build up the story and we will tell you what exactly to be done, what are the other applications that can be followed from that, and what are the modulations we can do, right? So that's it. So in today's lecture, we will discuss electrostatic 1. So why I have written electrostatic 1 without writing anything else? The reason is that we have divided the portions into few categories, let us say 4 or 5 portions. I will not discuss much about that because otherwise this surprise element will be killed. I do not want to kill it. So we will divide all the portions into separate elements and we will cover. Suppose if electrostatics is covered in 4 elements, similarly wave optics will be covered, ray optics will be covered, electromagnetism will be covered, modern physics will be covered. We will finish the entire syllabus so that you are having the total broad spectrum for JEE Advanced preparation, and you can really go with full gun blazing with full preparation to the exam hall. So in this electrostatic 1, I will be predominantly talking about 3 things. One is Coulomb's law. Second is application of Coulomb's law in a whole lot of different cases. There will be quite a few topics which can be co-linked to this Coulomb's law. We can drag explanation from mechanics, majority mechanics like SHM, rotational dynamics, Newton's laws of motion, work energy and power. We will show everything. Then the third part will be a little bit introductory part of electric field in terms of field line representation, and then we will see few application of flux, that is Gauss law. And after that, in the next class, we will come out with detail of electric field and detail of flux, and we'll proceed a little bit in terms of potential and potential energy, right? So without wasting much time, let's proceed. So first we will talk about Coulomb's law. Everybody knows Coulomb's law since this is a JEE Advanced class, so I will not talk about the elementary things. You can see that this is the diagram where there are 2 charges, Q1 and Q2. They are separated by a distance R21. So if I write vectorially, we can write that F vector, if I write Ij, K is 1 by 4 pi epsilon naught, all of you know, Qi, Qj by Rij cube Rij vector. So as you can see here that they will form action reaction pair, and this action reaction pair will cancel each other. Now the point is that here this is the coordinate form. I can write Rij, if it is given in a specified format, I can write x2 minus x1 I cap plus y2 minus y1 j cap plus of z2 minus z1 k cap. Now from there I can figure out the value of Rij mod also. So that will be this entire thing, whatever you are saying, root under of x2 minus x1 square plus y2 minus y1 square plus of z2 minus z1 square. We can put the result over here and we can get the coordinate form of Coulomb's law. I don't think that will be very much applicable, but it is very important to know the basic crude form. Now going to the next page, here we will try to understand the nature of Coulomb's law, and that is very, very important. So we will learn one by one what are the special criteria and what are the special formats. First, This is the law everybody knows, that 1 by 4 pi epsilon naught q1 q2 by r square into r cap. With a little bit of understanding, I can convert this r cap to r vector. So this is coming. And then we can see that there are two conditions which are met simultaneously over here. What are the conditions? Conditions are, first of all, magnitude of this force is proportional to 1 by r square. All right. So it is following inverse square law. And the second format is that this force direction is towards plus minus r cap. Now I will just explain a little bit here. When I am writing plus r cap, generally it means the force is repulsive in nature. All right, it's very simple to understand. When I am writing minus r cap means the force is attractive in nature. But that's not my point. My point is that plus minus r cap means the force is either radially outward or inward. That's the most important point. So 2 points are covered here. One, that the force is following inverse square law. Magnitude of the force is proportional to 1 by r square. And the second is that the force is either radially outward or radially inward. So when these two conditions are met simultaneously, not separately, again I am repeating, when these two conditions are met simultaneously, this force is basically called central force. This force is called central force. So what are the special salient features of a central force? What do you get? So in central force, as you can see, if I do r cross f, putting out this constant term outside, r cross r. Now we all know cross product between two similar vector yields 0. So r cross f we are getting 0. So r cross f is nothing but we know that is torque. This is nothing, simply this is torque. So if the torque applied on a system is 0, torque can also be interpreted as rate of change of angular momentum. So if rate of change of angular momentum is 0, then angular momentum must be conserved. So that is one point we must know, that in a central force field, angular momentum is always conserved. And we have to know one more aspect, all the central force fields are basically conservative in nature. So in a conservative force field, total mechanical energy will also be conserved, correct? So these are the simple informations we need to get about Coulomb's law, right? Now we are going for the application part. First I will show you a very simple application. I will show you a couple of methods to do it, and then slowly and gradually we will uplift the standard. हम देखेंगे किस तरह का JEE advanced question आता है. चलो. So there is a very famous pith ball problem. All of you know that there are two silk threads. With the help of two silk threads, two balls are hanging and they are in equilibrium. What is the condition of equilibrium? How to achieve it? Simple. So here there is the ball, you can see. Here is the electrostatic force in this direction. Considering both charges are positive in nature, right? I am not going to consider any negative charge. This is vertically downward force, mg, and the tension is passing to this point of suspension, correct? Now there are several methods of doing this particular question. I will note one by one. Method 1, we can solve it by force method. There is a method 2 through which we can solve this question, that is called torque method. And there is another method also which I call method 3. Method 3 is basically the condition of static equilibrium that we get, that is called Lami's theorem. I hope all of you are well versed with Lami's theorem, right? Fine. So I will show one by one. So first, force method is very simple. This T, so this component will be equal to T cos theta, and in this direction you will get a component which is equal to T sin theta. This is basic level stuff. I am explaining this question because I know this is not JEE advanced standard. I am explaining this question because the moment I will go to the next question, so that you see that what's happened exactly before and now, this is the direct analogy we are drawing. So for equilibrium, we know that summation of fx is equal to 0 and summation of fy is equal to 0. What do they mean? That net force acting along x-axis is equal to 0, net force acting along y-axis is also equal to 0. So in that case, we know that we will get T sin theta is equal to Fe and T cos theta, that is equal to mg. So if you divide, you will get tan theta is equal to tan theta is equal to Fe by mg. So basically this I have applied method 1. So with the application of method 1, we can get tan theta is equal to Fe by mg. Pretty simple, dead straightforward. So now I can apply method 2 also. Method 2 is the torque method. So I want to see it in detail. What is torque method? देखो यार, Fe is acting in that direction, mg is acting vertically down, and T is passing through the point of suspension. I'll just make a simple diagram. This is Fe in the horizontal direction. This is downward mg, and in this direction tension is acting. So if T is passing through the point of suspension, and if the system is in equilibrium, and if I take point of suspension as the reference point, so T is passing through this point. So if a force is passing through this point, means it will not generate any torque. So there is no torque due to T, tension. But there will be torque due to these two forces. Obviously rahega. So somehow if these two torque counterbalances each other, then the system will be in equilibrium. So that's the funda of torque method. So what we can write here? I will simply write, ab dekho, this is Fe. If this is length L, this length is going to be L cos theta, isn't it? Correct? And what about this length? This length is going to be L sin theta. So force into perpendicular distance, simple calculation, ठीक है ना? So I will write Fe into L cos theta is equal to mg into L sin theta. So the result outcome will be same, that is tan theta is equal to Fe by mg. There is no deviation of the ultimate final answer. So that means both the processes are correct. Yes, they are correct. I have just shown you two strategy, two different way how to see that perspective, right? Fine. So now if I look at method 3, I have told this is Lami's theorem. What is Lami's theorem? Lami's theorem says that if more than two forces are setting up equilibrium, or if they are passing through a common point, if they are concurrent, then they will establish equilibrium of a system. So in that case, force vector divided by sine of opposite angle becomes constant. That's Lami's theorem, right? So what can I do here? I will simply write Fe by, come to the diagram, Fe by, what is the opposite angle? This is the opposite angle. Are you following with me? This is the opposite angle. How much is the opposite angle? This is pi minus theta, so opposite angle is pi minus theta. So I will write Fe by sine of pi minus theta, right? That should be equal to mg by, what is mg here? This is mg. This angle is pi by 2 plus theta. So I will write sine of pi by 2 plus theta. If you calculate, similar calculation will be followed. I do not want to crumble up the space more. This is very simple calculation. You will get tan theta equal to Fe by mg. Same answer you will get, right? So that means whenever such questions are coming, if there is a point of equilibrium, if there is a discussion of equilibrium, you can attack the question from three different point of view. Either you can attack the question in terms of force method, or you can attack the question in terms of torque method, or you can attack the question in terms of Lami's theorem also, right? But there is no hard and fast rule that the body will be in equilibrium always. So if the body is not in equilibrium, in what way we can tackle the question, we will see. We will definitely check it out. Fine. Now this is a very interesting, intriguing Irodov question that I am picking out here. It is based on the same concept, little bit twisted, not much difference is there. So you know what they are saying, that there are two small equally charged spheres, each of mass m, equally charged spheres, the charges are same, are suspended from the same point by silk threads of length L. The distance between the sphere x is much less than L. Find the rate dq dt with which the charge leaks off each sphere if their approach velocity varies as v is equal to a root x, where a is a constant. So if we look at the diagram, this is the diagram basically. Two silk threads are there. We are focusing only one charge ball here. For that, forces are given. This is Fe, this is mg, and this is tension T. So immediately what I am going to do, this is L, right? And the total distance is x. So half of the distance, this I can write simply x by 2. Alright, I will see the calculation. Now, see here, In this case, as I have mentioned, this is length L over here and this is x by 2. All right. So I will follow the previous funda. If the system is in equilibrium, I already got the result. What is the result? The result is tan theta is equal to Fe by mg. I am going to follow this one, right? So एक बार देखते हैं. So what is Fe? Fe is simply equal to k q square. Since they both are same magnitude, so k q square divided by x square. Can I put the result here? Surely I can. Why I can't? I can. So let us put the result. So I can write tan theta is equal to Fe by mg, that means k q square by x square mg. All right, fair enough, no problem, no? Right. Now here they have already said that x is much less than L. If you can recall, x is much less than L. So what does it mean? I can write that tan theta in that case is nearly equal to sin theta, which will be equal to x by 2 divided by L, which is equal to x by 2L. So x by 2L is nothing but tan theta. If I substitute the result, what I am going to get? I will get x by 2L is equal to k q square by x square mg. Cross multiply and we are getting x cube is equal to, right side you will get few constant. What are they? 2kl, this L will go there, divided by mg into q square. Now this is the standard equation with which we are going to build our story. This is the standard equation with which we are going to build our story. So what the question was demanding? The question was demanding to find the leakage of charge, dq dt, the rate. So to figure out the rate, I need dq dt. So if you look at this equation right now, what we need? Simply we have to differentiate. So if I differentiate, I will get the answer immediately. So if I differentiate this equation, after differentiating, what I am supposed to get? I will get 3x square dx dt is equal to 2kl by mg 2q dq dt. Hold on, we got your answer. Why? Now you see, we want dq dt. dx dt is nothing but velocity, for which they have already given the result is a root x. So what is my job? Simply I will put the data and I will get the answer. So whenever the questions are coming, even if it is from Eurodob, you don't have to panic. There is a way out. And the way out is very simple. If you think from the fundamental point of view, you will get perfect answer at every point of time. There will not be any problem. Correct? So it is clear to all of you. I have used the previous data. From the previous data, I have used the approximation given in the question. And from the approximation, I have just differentiated the result, and after differentiating, we got the answer. Simple way. इसमें ज़्यादा कुछ सोचने का है ही नहीं. ठीक है ना? Right. चलो. तो next example पे चलते हैं. Now this is a very interesting example. I want to design this question in a different way. I want to have some qualitative discussion on this. So how will you do it? So for that, I will take, there are two charges separately. Suppose capital Q and capital Q, and I want to bring a third charge over here. I am not saying it is minus Q, I am saying it is Q1, simply. And if the Q1 is in equilibrium, I want to discuss the nature of equilibrium. That's the agenda. So first of all, for equilibrium, what is the condition? Condition is the net force has to be 0. We know for equilibrium, F net should be equal to 0. अब इसमें यहाँ पे गलती होता है. While finding out the pair of forces, a lot of students used to do a common mistake. Here F net equal to 0. कहाँ पे F net 0 है भाई? In the system only ना. The total force acting on the system must be equal to 0. तो कैसे उसको 0 करेंगे? भाई देखो, Q and Q, these two will interact. ठीक है? With that there is an interaction between these two. फिर से इसको ले लोगे तो that means the same pair will be repeated. I repeat once again. This Q is interacting with this Q. ये farthest interaction है. एंड दिस स्मॉल q1 इज इंटरेक्टिंग विद दिस कैपिटल Q, ये स्मॉलेस्ट इंटरेक्शन है, नियरेस्ट इंटरेक्शन, तो ये दोनों ही इंटरेक्शन है, कोई दूसरा और इंटरेक्शन है नहीं. सो दैट मीन्स आई विल राइट k capital Q square, k capital Q square by 4d square plus, correct, this is the force, and between them k small q1 capital Q divided by d square is equal to 0, and I know the answer, q1 will be equal to minus of q by 4. मिल गया. तो अगर if the charge is minus q by 4, definitely we are going to get the equilibrium in this situation. Point is, what is the nature of equilibrium? That is a qualitative discussion. Think. So if this charge, I finally got it to be minus capital Q by 4, what type of equilibrium is this? And for that, what we need to do? We have to give perturbation. Perturbation is a mathematical term. It means small disturbance. It's not like that charge बैठा हुआ है, जाके लात मार दो भाग गया वो. It's not like that. We have to give small disturbance, and small disturbance means we have to displace the charge particle by a very nominal distance. So if I disturb the charge particle in that direction, qualitatively think what will happen. So the charge particle is given a push in that direction. Suppose this amount is, I am writing x, and I have assumed already that x is much less than d. कोई problem नहीं, x is much less than d, and I have pushed the charge particle in that direction. So what about this distance? तो छोटा हो जाएगा ना दोस्त. That is d minus x. What about this distance? This is d plus x. All right, and we know one thing, that this electrostatic force inversely proportional. It follows the inverse square law, 1 by r square. That means here the distance is decreasing. So force between these two, if I call it f prime, will increase. Is that clear? Right. So if the distance is reducing, this force will increase. In that case, the distance is increasing. So if the distance is increasing, so definitely force, if I call it f double prime, it will be decreased. So that means the gap between the forces is increasing, which is not a desired scenario. अगर आपको equilibrium चाहिए, if you want stable equilibrium, the gap between the forces should not keep on increasing. ठीक है ना? If the gap between the forces is increasing, then there will not be any restoring force or restoring torque. So that means what? In this case, the charge particle will continue to accelerate in that direction towards that capital Q, towards the charge B. So if it is accelerating towards the charge B, that means there is no point of stable equilibrium, there is no point of unstable equilibrium, neutral equilibrium. There is only one case which is remaining, and that is the case of unstable equilibrium. I repeat once again, that in this particular case, since the distance between or the gap between the two forces is continuously increasing, so in that case the charge particle will continue to accelerate towards B, and the equilibrium will be unstable equilibrium. Correct? Can we have some case where similar kind of situation will be given and yet the charge particle will be in stable equilibrium? क्या हमको मिल सकता है? देखते हैं. Let's move ahead. So now suppose we have a situation like that. ये हम लोग के पास एक situation है. Here the same two charges are present. The same minus q is also present in the middle. अब उसको ना ऊपर लिफ्ट किया गया. It is given a push in the upward direction, perpendicular to the line joining. So now we will discuss what will happen. देखते हैं चलो. So as you can see, these are the two forces, f theta and f theta, acting towards this line. Can I divide it into two components? Yes, I can. So this is fy and this is fx. I have taken this f theta. If I take this f theta, in the same direction we will get fy, and in this direction we will get fx. ठीक है? अब चेक करते हैं. It's a very interesting thing. So now you can see that summation of fx will become 0. ठीक है? Summation of fx is equal to 0 because two equal and opposite forces are acting. So that's why summation is 0. तो मतलब x direction में तो कोई movement नहीं है. The particle will not have any movement in x direction. But there is a finite force acting along y. So f net is equal to 2fy, correct? And how much is 2fy? 2f into cos theta. I hope all of you are fine. This is theta, 2f cos theta. Now let us check 2. I will not alter this value of f right now. Cos theta equal to how much? Cos theta is simply y divided by root under of y square plus d square. Is that fine? Clear? Now let us bring f. So that is 2 into k small q capital Q divided by, this is the distance. So it will be root under of y square plus d square whole square into y by root under of y square plus d square. So if I see the entire result, if I see this portfolio, so what we can get is 2k capital Q small q divided by y square plus d square whole to the power 3 by 2, that into y. So when we look at this particular equation, no way there is any chance that equilibrium can be established. But I have already mentioned, to check equilibrium, to check equilibrium, you need to first understand one aspect. What is that aspect? That the disturbance should be very small. वो बहुत ज़्यादा नहीं होना चाहिए. So if the disturbance is small, so can I have the criteria? मैं क्या लिख सकता हूँ? If you give me the permission, नहीं दोगे तो भी लिखूंगा. That is, y is much less than d. So I can write that condition, that y is much less than d. So if that is the case, then what I am going to get? The same equation will be curtailed to f is equal to 2k capital Q into small q into y divided by d cube. Now this is pretty interesting, because the moment if you remove this term and if I put a vector notation over here, this is along minus j cap. So that's pretty interesting. Hold on. The charge particle here in this case is displaced along y. So this is plus j cap. But the force acting for a small disturbance is along minus j cap. So that means force and displacement vector are anti-parallel to each other. And not only that, force is also proportional to the magnitude of the displacement. So if it is valid for force, why can't it be valid for acceleration also? So that means A is proportional to minus y. So if A is proportional to minus y, what kind of motion is this? This is nothing but, we all know the motion is called SHM. That is simple harmonic motion. And we know simple harmonic motion is basically a motion where charge particle tend to be in stable equilibrium. Kyun? Because the moment you displace it from its mean position, it will try to come back once again to the same position. So this kind of motion we call SHM, and in SHM, a charge particle tend to be in stable equilibrium. So in that case, which equilibrium we have achieved? Stable equilibrium. Previous case, unstable equilibrium. So that means based on the direction in which you are projecting the charge particle, the notion, the idea of equilibrium can be different. Right? You have to be circumspective. So I hope this is clear. There is no doubt whatsoever. अगर आपके पास कुछ doubt रहता है तो comment box में comment कर देना, मैं answer कर दूंगा. ठीक है? चलो. Next. Now when we have learned about the basic condition of equilibrium, when we have learned about how to deal with the equilibrium cases, now we are going to see a little bit different kind of question. So first let us read out the statement of the question. It's saying, the smooth fixed rod is inclined at an angle theta to the horizontal. At the bottom end of the rod, there is a fixed charge capital Q. So there is the fixed charge. Alright. There is a bead of mass M having charge Q that can slide freely on the rod. The equilibrium separation between the bead from the fixed charge is x naught. That is interesting. So that means this initial distance is x naught. Alright. No problem whatsoever. Find the frequency of oscillation of the bead if it is displaced a little. तो हम लोग को पता है कि जब भी क्वेश्चन में द लिटिल बोल का आइडिया आता है ना कहीं बॉस SHM का झोल है. So that is the idea that we will get from the question. See, whenever you are going to read the question, whenever you are going to see a question that comes in the JEE Advanced exam, having a proper view of the question, having a proper idea of the question is very important. ठीक है ना यार, आइडिया ऐसा नहीं होना चाहिए कि आपको वो कोई बोला गया, somebody has said कि ट्रांसलेट करो अंग्रेजी में कि लड़की नीचे खड़ी है, तुमने बोल दिया, उस ट्रांसलेशन है मिसअंडरस्टैंडिंग, ऐसे नहीं होना, ठीक है ना. You have to have proper idea. Okay, so now I am going to bolster on this idea. So first of all, when equilibrium distance is mentioned, I am going to write the condition. Condition क्या है देख लेते हैं. This is mg and we know that this component is going to be mg sin theta. So equilibrium distance मतलब two forces are counterbalancing each other. So I will write k capital Q small q divided by x naught square is equal to mg sin theta, and this is the equilibrium condition. So this condition we call it equilibrium condition. Well, done and dusted. Now I will check, I will disturb it from the equilibrium. So if I disturb it from the equilibrium, I will check what is happening out there. So let's check. So what I will do now, I will simply do one calculation. I will put this charge little towards this one, and I will assume that this small amount is x. So if that is x, the current position of the charge is here. So this force or this distance will now be x naught minus x. I don't think there is any problem, correct? And I am assuming that this displaced distance x is much less than x naught, correct? So now try to understand what are the forces. Here plus capital Q is there, here this small q is there, and this distance here is now x naught minus x. So what are the forces acting? I can easily write the forces. The forces acting in this direction, now there is F electrostatic, and in this direction same mg sin theta. Alright. So what is the net force along this line joining? So F net is equal to, can I write F electrostatic minus mg sin theta? Although it doesn't make any significant difference, you can write the vice versa also. The game is all about the direction. We will check it later. So F electrostatic is how much? Now K capital Q small q divided by x naught minus x whole square minus of mg sin theta. You all know that to check the condition of SHM in any case, whether it is electrostatics, there is some question in SHM itself, some question can be given in modern physics also, in electromagnetic induction also, motional EMF. In all the cases, to check the condition of SHM, आपको क्या करना पड़ता है? By binomial theorem. You have to take the help of binomial theorem. So I will first redesign this term so that we are able to reach up to that extent. कि now we are ready to use the binomial theorem. कैसे करेंगे? Simple. K capital Q small q, let us pick x naught square out of this bracket. So क्या मिल जाएगा? We will get 1 minus x by x naught whole square minus of mg sin theta. Alright. So now let us follow that calculation. उसको हम लोग focus करेंगे कि what I will get if I do this one into binomial theorem, what I am going to get. So now I will get F net is equal to K capital Q small q by x naught square. This will become 1 minus x by x naught whole to the power minus 2 minus of mg sin theta. Right? After binomial is done, you can write, see here, now I will do direct calculation. K q by x naught square minus mg sin theta will make it to 0. Why? Because that was the equilibrium condition. You want to check? See here, that is the equilibrium condition. So K capital Q small q by x naught square minus mg sin theta will make it 0, right? So that means here, this first quantity will make it 0. Surviving quantity is minus of K capital Q small q divided by x naught cube. For binomial theorem, these 2 comes here. So this minus minus plus 2 into x. So that is F net. Hold on. Now you are ready to attack me. कि सर, आपने बोला था कि for SHM, F has to be proportional to माइनस एक्स और माइनस वाई, यहां पे तो प्लस एक्स आ गया, नहीं आया दोस्त. You have to understand the concept. Concept is that, see, displacement in which direction I have done. भाई मैंने displacement कहां पे किया था? Displacement is in this direction. Correct है? Force कहां पे है? इस direction में. So this is F net and this is displacement. So दोनों तो opposite हो गए ना भाई? Correct? ये तो magnitude है. So that means here in this case also, what are you getting? SHM. SHM मतलब कौन सा equilibrium? Stable equilibrium. Fine. So if it is stable equilibrium, then we can find out this is equal to m omega square x. So angular frequency omega root under of 2 capital Q small q divided by m into x naught cube. ये हो गई हमारा आंसर. All right. Straight and simple. But wait. Here you have to remember one thing. I don't know whether you have observed it or not, but there is a very, very interesting point here. What is the point? Point is, देखो यार हम लोग mg sin theta लेके बात कर रहे थे. We were talking a lot about gravitation. नीचे डायरेक्शन में mg sin theta काम कर रहा है. Electrostatic force was balancing it. But when final answer came, is there any hint of g here? अब देख पा रहे हो? है कहीं पे? नहीं है. In fact, in most of the questions that you have solved in SHM chapter, you will see that gravitation is not very frequently coming in the answer. Reason क्या है? Now मैं एक shortcut trick बताता हूँ, ध्यान पे रखना और execute करने का कोशिश करना. Point is, in SHM, most of the constant forces do not contribute. क्या बोला मैंने? In SHM, most of the constant forces do not contribute. They will not contribute into the SHM. SHM में वही फोर्स कंट्रीब्यूट करते हैं इन जनरली जो फोर्स वेरिएबल होते हैं एंड इंपल्सिव होते हैं. दैट इज ऑल्सो वेरी इंपॉर्टेंट पॉइंट. आई डू नॉट वांट टू डिस्कस दैट इन डिटेल राइट नाउ बिकॉज वो स्कोप नहीं है. आगे आगे बढ़ेंगे तो आई विल जस्ट ओपन अप लाइव एनीथिंग. दिस इज द फर्स्ट लेक्चर, सो वी आर कीपिंग द स्टैंडर्ड नॉट वेरी हाई. फर्स्ट वी विल गेट अकस्टम टू यू. आपको थोड़ा कॉन्फिडेंस देते हैं, उसके बाद आई विल टेक द जर्नी अलॉन्ग विथ यू. तब हिमालय पे भी चढ़ जाएंगे, कोई इशू नहीं है. राइट? तो आई होप this is okay for all of you. You have seen that how to develop the questions around SHM जो Coulomb's law को connect करता है and how to execute those questions. Right? बहुत difficult नहीं है, कर सकते हो आराम से. ठीक है? Okay. Now, next going ahead, here I am going to take a case, a typical case, and the case is basically connecting Coulomb's law with rotation. So try to understand. I have connected first Coulomb's law with force. Then I have discussed Coulomb's law and equilibrium cases. Then I have taken the condition of equilibrium. I have discussed the type of equilibrium. Then I have taken the case of SHM. Then again I have taken the cases of SHM. I gave you few takeouts of that particular question or the discussion. Now I am going to take you through a tour where we will apply certain kind of rotation also. So see, this is the way of studying, this is the way of developing a subject, this is the way of developing a content in JEE Advanced. In JEE Advanced, if you just read what is written on the book, what is given in the lecture note, you will be never be able to cross the bar. अब कभी नहीं कर पाओगे because it is very very important. आपको ये पता होना चाहिए कि from what point of view the subjects are asked in JEE Main, JEE Advanced. You know, they will not give you any direct option. They will not give you any direct question. आपको उसका मूल पकड़ना पड़ेगा. You have to understand the fundamental part of that particular problem. What is the basic concept they are asking. अगर वो आपको पता हो गया, then आप कुछ भी कर सकते हो. And the second most important thing is that कि sir, I study a lot and I forget a lot. मैं भूल भी बहुत जाता हूँ. दोस्त भूल जाओगे तो एग्जाम भी तुमको भूल जाएगा. In JEE Advanced there is no scope of forgetting because most of the questions, on a very serious note, most of the questions are multi-layered questions. एक क्वेश्चन में 2, 3, 4 कंसेप्ट इन्वॉल्व होते हैं. अगर आप भूल जाओगे डेफिनेटली देयर विल बी मिसिंग लिंक, और अगर कोई एक लिंक छूट गया यू विल नॉट बी एबल टू रिकनेक्ट इट, प्रॉब्लम हो जाएगा. ठीक है, चलो आगे चलते हैं. So in this question, let us first go by the statement. What it is saying? A uniform non-conducting ring has mass m and radius r. 2 point charges small q and q prime are fixed on its circumference at separation of root 2r. तो फर्स्ट डायग्राम पे चलते हैं. बॉस, दिस इज द सेंटर. देयर आर 2 चार्जेस स्मॉल q and q prime and this is R, this is also R, and they are saying कि this is the separation which is equal to root 2R. So we all know अगर वैसा होता है तो सिचुएशन क्या होता है दोस्त? This is R, this is also R, and this is root 2R. So that means this angle should be 90 degree. और हम लोग यहाँ पे वही कंसिडर करेंगे कि this angle is basically 90 degree. So in that question, the way that they have given कि this is the circle, and in that circle there is one charge here, and that charge they are saying, let us say Q, they are saying this angle is theta, and here I have another charge Q prime, so this angle must be 90 minus theta. इतना ही पॉइंट है बस. देखो छोटे छोटे तरीके से कैसे ये लोग डिस्कशन को और इंफॉर्मेशन को एम्बेड करते हैं. विल इनग्रेन द इंफॉर्मेशन इन द क्वेश्चन. यू हैव टू फिगर आउट द इंफॉर्मेशन फ्रॉम द क्वेश्चन. यू हैव टू प्लक आउट द इंफॉर्मेशन फ्रॉम द क्वेश्चन, राइट? लेट्स मूव अहेड. They are saying that the ring remains in equilibrium. Very, very important. The ring remains in equilibrium in air with its plane vertical in a region where exists a uniform vertically upward electric field, and the value of the electric field is also given. So first we will build up around the cases. We will not see what they are asking. नहीं देखते हैं पर case build up करते हैं. So let's move on. So here in this case, if the electric field is vertically upward, definitely we can write कि in this direction Q prime into E. This is the force acting, all right? And there will be another force in that direction which is Q into E. Okay, आराम से करते हैं, ठीक है? Peacefully, no hurry. So दो forces हो गया. Any other force is there, है ना? Check करो in that question what they are saying, that 2 point charges are fixed on the circumference and the ring is given, there is a uniform vertical field. ये देखो, they are saying that the given E is equal to 4 mg by 7 q. मतलब the charges both are equally carrying mass m. तो अगर वैसा होता है तो क्या मैं लिख पाऊंगा कि भाई in that direction there is force mg, in this direction also there is force mg. So total downward force कितना हो जाएगा बॉस? So I can write Q prime E plus QE, that is equal to 2 mg. So this is my equation number 1. All right. So एक condition हो गया. Got it? So the moment you got one condition correct, so for equilibrium, what is the important fact? कि net force summation of F equal to 0, that is one condition, and another condition is that net torque is equal to 0. Now hold on to this point. Net torque is equal to 0. Net torque about what point? अरे यार आपके सराउंडिंग में इनफाइनाइट पॉइंट हो सकता है. आप बोलोगे कि सर मैं अर्थ पे बैठा हुआ हूँ फ्रेम पे, कोई एक दूसरा फ्रेम पे पॉइंट ले लूंगा एंड आई विल कैलकुलेट टॉर्क अबाउट दैट पॉइंट. तो ये मेरा कंडीशन को सेटिस्फाई करेगा क्या? नहीं करेगा ना. So that means here in this point you have to be extremely careful when you are writing net torque equal to 0. You have to remember that this torque must be taken about a point inside the system. ठीक है ना? हैमर कर लेना दिमाग में. We have to take the net torque about any inside point of the system. तो जो point system के अंदर में है, the point which is lying inside the system, about that only I have to take this torque equal to 0. तो about any point inside the system. All right. So about point inside the system. Now I will take this point simply. Suppose मैं इस point को ले रहा हूं. That is the point. That is the center. So about the center, if I calculate the torque, let us see. Check कर लेते हैं एक बार. So that means, okay, fine. So that means Q prime into E. This force will give a torque. इसका वो torque देगा, right? So if that is Q prime into E, and this will become R of sine 90 minus theta. All right. This should be equal to Q into E R. This is the perpendicular distance. So R sine theta. So that's the point there you have to agree upon. Correct. So the torque provided by these two forces must be equal if it is in equilibrium. By the way, in the question you see, they have mentioned the non-conducting rod has mass m, correct? And the 2 point charges q prime are fixed on the circumference. So that means यहाँ पे एक थोड़ा सा change करना पड़ेगा. If this is having mass m, so I will take these two masses as m prime and m prime, correct? So I will write 2 m prime into g plus mg, because this mg will act through this point. ठीक है ना? अच्छा, point is there will be another torque due to m prime g, correct? थोड़ा सोच लेते हैं. देखो यार, if these two are having the finite masses, then they will also provide torque about this particular point, and these two torque will cancel each other because these two are equal in magnitude. These two perpendicular lengths are also same. Are you getting my point? Perpendicular lengths are also same. Then क्या होगा? That torque will not be contributed. खाली ये वाला equation आ जाएगा. Now this is my equation 2. So now if you solve equation 1 and 2, you are going to get your desired answer, right? Correct? So let's see once again, how did we build up the case? So first of all, from the given information, we picked out that the angle is 90 degree. So if the angle is 90 degree, this angle is coming to be 90 minus theta, correct? So in that case, 90 minus theta, if it is in equilibrium, so two conditions will be maintained. One, this net force has to be equal to 0, and the net torque about any inside point has to be equal to 0, and from that we will get the answer. इसमें एक और चीज पूछ रहा है, the ring is given a small rotation in the plane of figure and released, will it perform oscillation? We have already checked, and now we know 100% it will execute SHM. It will execute SHM because when you rotate in any of the direction, then either due to this force or due to this force, there will be a disbalance in torque, and that torque will act in the opposite direction and it will bring the system back. So there will be an oscillation in the system, and that oscillation we can prove also, that I am leaving out to you for your convenience. You can work out on your own that here angular oscillation will be established. I am just giving you one hint so that it becomes very easy for you. Basically we have to write tau is equal to I alpha, and you will get an equation like tau is nothing. Here alpha is equal to, you will get tau by I, and you will get the equation in the form d2 theta dt2 plus omega square theta is equal to 0. You will get the equation in this form, and this is nothing but equation of angular SHM. So here in this case also you can figure out what is the angular frequency of oscillation. Anyway, so let's move on. Now I will come into a very interesting thing. I will repeat once again. हम लोगों ने क्या क्या cover किया? We have covered force, we have covered equilibrium, we have covered nature of equilibrium, we have covered SHM cases, we have covered a little bit of rotation also. Now we are covering a particular thing which will be connecting to kinematics in electrostatic Coulomb's law. So let's see, let's explore that. What is that? So here is saying that an electron of E and mass m is projected horizontally into a uniform electric field produced between two oppositely charged parallel plates. Diagram we will see. They are having plus minus sigma charge distribution. Separation between them is d. You have to assume that only electric force acts on the electron. So this is a very crucial information. That means it's a gravity free space. All right. So the moment they are saying that only consider the electric force, means it is a gravity free space. We will not consider gravitation as a potent form of force over here. And there is no field outside the plates. So that means the field is restricted strictly in between the plates. They are saying initial velocity of the electron is u parallel to the plates along the line bisecting the gap between them, and the separation is 2L, blah blah blah. Find sigma if the electron. We will not go into the question demand. We will see the cases built up around this. So let's see. So this is the diagram. So the plate separation is categorically D. It is divided into two parts, d by 2, d by 2. Electron is projected from here. So now this is positive and this is negative plate. So we can write that the field will be from positive plate to negative plate, and it is perpendicular to the initial direction of motion. कुछ आ रहा है idea? हाँ, सही सोचे. It is projectile motion only. So now we are going to see a case which will involve the cases of projectile motion. तो देखते हैं. See here. Now this is the direction in which electric field is there. So that means electron will be feeling force in the opposite direction. Why so? Because we know F vector is equal to Q into E vector. Here in this case, this Q is minus E, so minus E into E vector. Now E vector is vertically downward, so F will be vertically upward. And the initial direction or initial velocity is in that direction, U. Correct? So can I write Ux is equal to Vx is equal to U, which is going to be constant. It's not going to change because that velocity is perpendicular to force. Correct? So why it cannot change? I will just remind you, because F is perpendicular to U vector. If that is the case, then in that case F vector dot Vx vector must be equal to 0. So that means the external force cannot deliver any power to the particle in that direction, hence it cannot change the kinetic energy. ठीक है ना? कितना इंटरेस्टेड केसेस रहेगा, कितना इंटररिलेटेड केस है. The moment you try to think, you will get a lot of idea. Correct? So that means what I am saying, that F vector dot Vx vector is equal to 0. This is nothing but dw dt, rate of change in work done. So that means if this is 0 means rate of change in work done is equal to 0. So that means dk dt इसका भी 0 हो जाएगा. We will not get any work done. So that means kinetic energy rate of change is equal to 0. That means U will remain constant. There will be no change in U. Fine. That is clear to all of you. So correct. So now let us get back to the question. So I will divide this question into 3 different parts. Or rather I should say I will divide this motion into 3 different parts. In what way? That first we will consider the motion from here to here. Then I will consider from here to here, that is along X. Then I will consider along Y. So 3 different ways we are going to deal the motion. I repeat once again what I have written here. So that means Ux equal to Vx equal to U, which is equal to constant. Ax, acceleration along X axis, is equal to 0. Acceleration along Y, that is simply equal to F electrostatic by mass of the electron. F electrostatic is how much? Q into E divided by M. From our knowledge, we know that electric field produced by here a single charge plate. So remember, electric field produced by plate sigma by 2 epsilon naught, but here the field is unidirectional, so both the plates are producing the electric field. So that means the net field E net will be equal to sigma by 2 epsilon naught plus sigma by 2 epsilon naught. The field will be sigma by epsilon naught. I can put the result here. So I will write Ay is equal to Q into sigma by epsilon naught M. So all parameters are there with me. I have Ux, I have Ax, I have Ay. Correct? Fine. So now, as I said, I will divide in different perspective. So what I will do, that first I will think from O to P. So let us concentrate from O to P. So the journey time T, O to P, I can comfortably write 2L by U, because the separation is 2L. Along that direction speed is constant, so I will write journey time TOP is equal to 2L by U. Alright, fine. So if that is 2L by U, can I get the velocity at this point V? Yes, I can. So velocity at the point B along Y is equal to Uy plus Ay into journey time from O to P. So we will keep everything simple so that you understand everything out of it. By Uy is equal to 0. So this will be simply equal to Ay into journey time from O to P. Ay I have already calculated. How much we got? We got Q into sigma divided by epsilon naught M. TOP how much we got? That is 2L divided by U. So this is the value of Vy. Vy at which point? At point B. Remember, this calculation we are doing at point B. So this is at B. Entire calculation is focused to point B only. So the moment we got the value of Vy, now you check here. This is Vy. this is Vx, and in this particular space E equal to 0, so F electrostatic equal to 0. Gravity anyway is absent, so from B to Q in this particular region, Vy and Vx, both are constant. So the region beyond point B, both Vy and Vx equal to constant. None of them is changing. कोई नहीं vary हो रहा. So that means in that case, journey time from point B to Q. See again here, Vx u तो constant ही रहने वाला. There is no change, and the length already given is L. So Tbq I can write L by u. Simple, no problem. So Vy is remaining constant. What I can write about Qc? Qc is simply Vy into journey time from B to Q. This one, correct? So what can I write? Vy I already got, Q sigma by epsilon naught m into 2L by u, that into journey time from B to Q, I have already got it, L by u. So that is Qc. Step by step we are exploring everything, right? It's very, very simple, not difficult, provided by the fact that you keep these things intact, you keep your concept intact. I will just repeat once again. From where we have started by saying ki boss, the electrostatic field is perpendicular to the initial u. So u is going to remain constant from O to P. From that I have calculated the journey time. Correct? From O to P. So after calculating the journey time, here it is calculated. Then after it is coming out point B, here in this space electric field is absent. So electrostatic force is also equal to 0. Gravitation anyway absent, they have presented in the question. So I don't have to worry enough about the gravitation. Correct? ठीक है, तो ये हो गया. तो Vy Vx both constant हो गए हमारे. And now what is the question demand? I will now go back to the question. I will see what they are demanding. Question का क्या demand है? They are saying that if find sigma if the electron hits the screen at a point that is at the same height as the upper plate. ठीक है, निकाल लेंगे, क्या दिक्कत है? So now यहाँ पे हिट हो रहा है. So total distance कहाँ से कहाँ तक कवर किया? यहाँ से यहाँ तक. भाई that is a d by 2 anyway only, no? इतना तो d by 2 ही है. So what I will write? I will write d by 2 is equal to, notice करो, Pb plus Qc. Very simple. How much is Pb? Pb is simply half into Ay into T, journey time from O to P whole square, plus of Qc. I have already got it. That is Q sigma 2Q sigma L square divided by epsilon naught m u square. Acha, we know Ay value. Where is Ay? Ay is this. We know journey time OP. Yes, we know journey time OP. I can substitute, I will get the answer. Simple. समझ में आई बात? बहुत simple है. So that means whenever you are seeing such question, whenever you are seeing such gigantic question, the safest way of working out is that you try to understand the underlying ethos of that question. If you get it, definitely you are going to hit the answer. Nobody is going to stop you. Correct? ठीक है, अब चलते हैं. Let us continue our journey. तो हम लोगों ने कहाँ कहाँ कवर कर लिया, एक बार पॉइंट आउट कर देते हैं. See, this is an 1.5 hour class, not more than that. So in that 1.5 hour class, you will be stunned to see that how much percentage we are covering. We will cover laws of motion, we will cover stable equilibrium, we will cover SHM, we will cover rotation, we are covering projectile motion and everything, right? Fine. So now we will discuss something related to electrical field line. So we all know the properties of field lines. I do not want to waste the time by discussing the properties of field line because the basic properties all of you know. I am going to build some story around that information which you already know. So here in this case they are saying that in a region of space an electric field line is in the shape of a semicircle. You can see magnitude of the field at all point is capital E. A particle of mass m having charge q is constrained to move along its field line. is constrained to move along the field line. This is very, very important. So that means if you just leave a charged particle, it is not mandatory that it will move along the electric field line, correct? And there is a theory which I will leave to your discretion. If you have doubt, you can comment on the comment box. We will hit back to you. This is a very, very interesting point. I will leave you two puzzle. One, we all know whether two field line can cut each other or not, but can they touch each other? This is one. I repeat once again. Two field lines can cut each other. We all know it. But what we have to answer is that, can two field lines touch each other? If yes, then why? If not, then why? Second point is that are electric field line and trajectory of a charged particle same? Listen to me once again. I am saying, are electric field line and trajectory of a charged particle same? If not, then why? So these two puzzles I am keeping you. You have to answer, right? Fine. Find its kinetic energy when it reaches point B. Find the acceleration of the particle when it is at midpoint of the path from A to B. It's a very, very simple question. We'll build a story around it. So let us build the story. So this is point A and this is point B. So you see, we know the tangent drawn to a field line gives the direction of field. So this is the field, right? Everywhere we will get the field like this. This is E, this is also E, this is also E, this is also E. And since the charged particle is moving, that will be the direction of force. So QE, 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 QE. No problem whatsoever. So that means if I take this straight line and if I take small position, this is theta and this is very small angle d theta. So for that very small angle, this is the displacement, that is ds. As you can see that force and displacement vector are parallel to each other. So dw, we can write f vector dot ds vector, and theta is basically equal to 0 degree. So if the angle between the vector is 0 degree, the vector dot product will be simply reduced to f dot ds. Interesting, you know? So f into ds means r d theta. So if I integrate, w is equal to fr integration of d theta. Limit will be from 0 to pi. Correct? 0 to pi. So how much it is getting? F into pi r, that is equal to kinetic energy at point B minus kinetic energy at point A. It is at rest. So kinetic energy at point B is equal to F into pi r. F is equal to how much? QE. So that is QE into pi r. This is the final answer. So this is a very interesting thing, correct? Now we can have a qualitative discussion on this also. मैं आपको घुमा भी सकता हूँ. कैसे? चलो देखते हैं. और सुनना ध्यान से, ठीक है ना? मैं एक बहुत इंटरेस्टिंग चीज बताऊंगा कि सपोज इट इज नॉट मैंडेटरी, इफ इट इज नॉट मैंडेटरी टू हैव कैलकुलेशन ऑल द टाइम. मुझे कैलकुलेशन नहीं चाहिए यार, मैं कोई दूसरे तरीके से सोचूंगा. कैसे सोचूंगा? देखो, सी दिस इज एफ इलेक्ट्रोस्टैटिक, ठीक है? दो कंपोनेंट निकाल देते हैं भाई. दिस इज एफ एक्स एंड दिस इज एफ वाई. ध्यान से सोचना, करेक्ट? नाउ similarly, I am going to take this displacement also. This is, let us say, delta r. So delta r will have two components. This is delta x and this is delta y. So if I keep on adding like this, can you understand? Again, it will go in that direction. So that is basically basic idea of calculus. Calculus of one variable, correct? So in that way also, by separating fx and fy, we can calculate what is the work done. But I will not encourage because it needs a lot of patience and understanding. Now the next question was very important. Question number 2. It was saying, find the acceleration of the particle when it is at the midpoint of the path from A to B. ठीक है? आप बोलोगे सर बड़ा सिंपल है, क्यों नहीं निकालना? Midpoint of the path is this. Force कितना? QE. What is the acceleration then? He will say A is equal to QE into E divided by M. हो गया ना? Job done. QE by M. There is no other acceleration, but wrong. They told you previously only that this particle is constrained to move, and whenever this particle is moving along a curved path, it is supposed to have radial acceleration, correct? So here in this case, this acceleration is basically tangential acceleration. This is well and good, no problem in it. But what about the radial acceleration? What about the normal acceleration? That is equal to what? V square by R. What V? V is the velocity here at the midpoint of the path. Do you know V? No, we don't know. Can we calculate? Yes, 100% we can calculate. In what way? Let's see. Same work energy theorem we will follow. Now since we know the basic, so we will apply directly. Q into E, that is the force, into path length from here to here, simply equal to how much? Pi r by 2. That is equal to m into v top square divided by r. So from here, sorry, this is mv square by 2, because this is the kinetic energy. So we'll get divided by 2. So from there, I will get v top square by r. See, these two cancels out. So v top square by r, we are getting qe pi divided by m. And this is the normal acceleration, right? So how much we got finally? We got A tangential is equal to QE by m, and A normal is equal to how much? Pi QE by m. So we have two acceleration, normal acceleration as well as tangential acceleration. So what is the net acceleration? So I can write total acceleration at the midpoint, A mid, is equal to root under of A t square plus A n square, because they are mutually perpendicular to each other. So I think QE by m will be common, root under of 1 plus pi square. This is going to be the answer, correct? It's a very intriguing question. It can confuse you, but do not get confused. Try to understand in a proper way. Fine. I will see one more example. So of field line, so that idea about the field line becomes crystal clear. All right, let's see. So here in this case, this idea of field line basically involves another concept from Gauss law, which is solid angle. So here is a field line which is originating from Q1 and terminating at point B. So I will just give you the brief idea so that you don't have to think a lot about the calculation. Say this is a Q1 and field lines are originating like this at an angle theta1, and here is a point Q2 where field lines are terminating at an angle of theta2. So we will build the story around like this. We will take this cone, this is also theta1, we will take this cone, this is also theta2, and we will assume that all the lines that are emanating from this charge like this are converging here like this. So if I see this conical face over here and if I see the conical face over here, we will build the solid angle concept. What is the flux here in this case? Phi out is equal to Q1 by epsilon naught. It is a total flux, and we know a point charge maintains spherical symmetry. So for a sphere, the solid angle is 4 pi. So per unit solid angle is 1 by 4 pi into. How much solid angle it is subtending? Simple formula, 2 pi into 1 minus cos of theta1. Alright. So this is the flux out of Q1. What is phi in then? Phi in will be equal to Q2 by epsilon naught. Q2 by epsilon naught is the total flux into 1 by 4 pi. Similar logic, because it is a point charge, so it will maintain spherical equilibrium, into 1 minus cos of theta2, 2 pi. So in this case, what is desired? Phi out must be equal to phi in, and you will get the condition. In the similar way, you have to solve this question. So this is not a very heavy duty question, it's a simple question which you can answer from here. And on the same concept, you see, on the same concept, this question is also built around. A frustum is cut from a right circular cone. The two circular faces have radii r and 2r, center at 1 and 2 respectively. Height of the frustum is h equal to 3r. When a point q is placed at 1, the flux of the electric field through the circular face of radius 2r is phi 1, and when the q is placed on O2, the flux through the other circular face is phi 2. Find the ratio of phi 1 and phi 2. I will use the same concept. I will write phi is equal to q by epsilon naught. What did I tell? This q by epsilon naught is what? This is total flux. Due to what? Due to the point charge. Alright, into point charge maintains spherical equilibrium. Again and again I am repeating so that you can understand properly. Into 1 by 4 pi into solid angle 2 pi into 1 minus cos theta. So we are going to solve this question from this angle. So let us see here. So first, when the q is here, so I am assuming first q is here. Can I take a cone like this? And can I say this angle is alpha? So this is also alpha. So phi 1 is how much? All of you tell me along with me. Phi 1 is equal to capital Q by epsilon naught is the total flux into 1 by 4 pi 2 pi into 1 minus cos alpha. So let us calculate how much is cos alpha. We will get an idea. So that is Q by 2 epsilon naught, because this cancels out with 2, into 1 minus cos alpha is how much? Cos alpha is this height, which is given to be 3r. H is given to be 3r. 3r divided by root under of 9r square plus r square. So this is phi 1. So phi 1 is done. So what if phi 2? Let us check. For phi 2, the charge particle will be positioned here. There is q. है ना? So if the q is there, I will take this cone now. So this is beta. This is also equal to beta. So what about phi 2? Phi 2 will be equal to q by, directly I am writing 1 to epsilon naught 1 minus of cos beta. So how much is cos beta? Tell me how much is cos beta. Achha, I think there is a point. The point is that this base is 2r, right? Okay. So that means here in this case, rather than r square, it will be 4r square. Alright, fine. So q by 2 epsilon naught 1 minus cos beta, same height 3r divided by root under of 9r square. Now this is r. So 9r square plus r square. So if you calculate, you are going to get the answer. What is the ratio of phi 1 and phi 2? Is that thing clear? So अगर आपको एक simple concept पता है and उसको execute कैसे करना है आपको मालूम है, तो आप easily कर सकते हो. कोई deal नहीं है, ठीक है ना? Even if it is a question of JEE advanced order, it doesn't matter. And I tell you, this is the concept which they keep on hitting. This is the question that the JEE advanced paper setter keep on hitting very now and often. ये आपको मिल जाएगा, right? ठीक है. अभी just 2 years back we got a question on this conical structure in the cylinder, and it was a multiple option correct question. It's a very good question, ठीक है ना? But if you know this concept, very easy to solve. Anyway, so now we are going to discuss the last case today, and in this case I will concentrate every single bucket that I have in my list. So I will infuse Gauss law, projectile, motion, everything. So without wasting much time, let's read out. They are saying electric field in xy plane is directed along positive y direction and its magnitude changes with y coordinate as E equal to ay square. A particle having charge q and mass m is projected at this point with velocity this. The velocity is along x-axis. Neglect all other forces on the particle. Apart from the electric force, calculate the slope of the trajectory as a function of y. So let's build the story. They are asking what? They are asking slope. So this is the question demand. And see how we'll penetrate the question slowly and steadily. So that is the slope. Do you know the formula for the slope? Yes, we know. Tan theta is generally Vy by Vx if there is a curve given y as a function of x, and the slope is generally written as dy dx. Further modification you can write Vy by Vx. So that's what slope is all about. So इनमें which quantity you know? We know that since the electric field, they are saying that is along y-axis, electric field is along positive y direction. So that means E is a function of y and that is along y. So force is also a function of y and it will act along y. So Fx is equal to 0. If that is the case, Vx is going to remain constant. So that means Vx is equal to V naught. That is known to us. But do we know Vy? No, we don't know. That means we have to build our story along Vy. I need to get Vy. But first, here in this case, they have already given that electric field is equal to Ay square. Point is, they may not tell you the electric field also. Like what? They can tell simply कि भाई there is a non-conducting charge density, rho is equal to Ay. Electric field भी नहीं बोला, निकालो इसका electric field. तो कैसे करेंगे? So if that is the case of electric field, then we have few ways of doing it. कैसे करेंगे? See, we will take a strip over here and we will say this is y distance, this is dy, correct? Here some flux are entering, let us say phi 1, here some flux are coming out, let us say phi 2, phi 2. So in that case, phi net will be equal to what? Phi net will be equal to charge stored in this region, that is dq by epsilon naught, right? How much charge is stored there? That is rho into dv. dv means a dy divided by epsilon naught. And this should be equal to what? This should be equal to E plus dE into A, flux minus E into A. So from there, if you cancel dE, how much you are getting? Rho dy by epsilon naught, correct? And rho is equal to what? They have given to be ay dy by epsilon naught. So E will be equal to how much? Ay square divided by 2 epsilon naught. ठीक है ना? बट ये गधा वाला स्ट्रेटेजी है यार, इसको करोगे तुम मर जाओगे एग्जाम हॉल में, कितना टाइम लेगा? You can't do. So this I have applied the differential, this basically entire thing dq by epsilon naught is basically the integral form of Gauss law. We can use what? We can use differential form of Gauss law. What is that? I can directly write dE dy is equal to rho by epsilon naught. अब देखो एक स्टेप में इंटीग्रेशन में रिजल्ट आ जाएगा, करेक्ट? जस्ट वन स्टेप इंटीग्रेशन you will get the answer. Fine. So anyway, once we get electric field, but here in this case electric field is already mentioned that E is equal to given. So can I write Fy is equal to Q into E? So that is Q into Ay square. Fine. So now once you get Fi is equal to Q into Ay square, Fy can I write m into Vy dVy dy? ठीक है ना? When you are writing acceleration, either you can write dv dt or you can write dv dy into dy dt. dy dt is v itself, so you can write v dv dy. To make you understand along y-axis, I have written mvy dvy dy, which is equal to q into ay square. If you integrate this result, vy you are going to get, substitute, you will get the slope, correct? So I hope that this thing satisfies you well. You have understood a hell lot of things, and I have taken you through a revision complete. As you can understand, I have taken a complete revision of mechanics itself through this Coulomb's law and its application and Gauss law and electric field line. So that will be my motto. Even though I am teaching the 12th, I will be completing the revision of class 11th itself, so that if you are having this complete session, you are having the full revision of class 11th itself, right? So if you think it is useful for you, if you think that you have really enjoyed this program and you have understood the crux of the matter, don't forget to subscribe us, that is Infinity Learn JEE. And if you want to know more, some other exciting information and packages and the course, do log on to our website. Thank you very much. Bye-bye.